Hi everyone, this is Legends in Learning channel, okay, and I hope you've liked and shared and subscribed to our channel. You share our videos, like, comment on our videos. This educational learning channel is an online institution or online learning space where we teach all students in levels of primary, junior high schools, and senior high schools. So today is another day, and we'll be real quick on this. This is a quick lecture. So we'll dive into our topic of the day. We'll be treating numbers. We'll be treating numbers as a junior high school Form 1 topic. Under numbers, we take the properties of natural numbers, and we'll look at our objectives. Our first objective, by the end of this lecture, if you're a student watching, you should be able to understand what is meant by natural numbers and what their properties are. And then, secondly, you should be able to provide a systematic way to determine whether a number is divisible by another number. And our last objective is you should be able to apply the knowledge of the natural numbers that we are going to get on my video today to various real life situations and mathematical problems. So let's quickly dive in. So the first question is, what are natural numbers? We all know numbers. Numbers counts from 1 to infinity, or some can count from 0 to infinity. So what are natural numbers? Let's look at what natural numbers are. So the definition of natural numbers, they are positive integers starting from 1 and extending infinitely. Okay, so they are natural numbers which are positive. Natural numbers are positive integers. When we talk about integers, we all know integers can be a negative or positive number, okay, and they start from 1 extending infinitely. So the symbol of natural numbers can be denoted as n, in the matter of fact capital N, okay, not small n, in a capital N. So let's look at some examples of natural numbers. Can count from 1, 2, 3, 4, 5, okay, and we can also have a negative 1, 2, 3, 4, 5. Since they are integers, integers can be a negative or positive number counting from 1, okay. Let's go to our next slide. We are talking about some subsets of natural numbers. Some subset of natural numbers. When we talk about some subset of natural numbers, we have heard them before, consisting of the prime, even numbers, multiples, and then counting numbers. So real quick, let's look at some natural subset of natural numbers. So our first subset should be even numbers. We all know even numbers, right? So even numbers are integers that are divisible by 2 without leaving a remainder. Okay, so they are numbers which are divisible by 2 without leaving a remainder. Let's look at some examples of even numbers. We have 2, 4, 6, 8, 10. So for you to easily remember when you see a number, to remember if it's an even number or not, even numbers normally skip count 1 starting from 2. So if you start from 2, you skip count 1. So skipping from 3 to 4, skipping from 5 to 6. So we skip count 1 in even numbers. So that's very easy to remember what even numbers is. And so on. Even numbers are subset of natural numbers because they can be expressed as product of 2 and the natural number. So this makes them qualify as a subset of natural numbers. Why? Because they can be expressed as a product of 2. When we take the product of 2, we have 2, 4, 6, 8, 10 to infinity. And then they can be expressed as natural numbers. Why? Because they are positive. Okay, they are positive numbers. Now let's go to the next subset of natural numbers. We have the odd numbers. The odd numbers are integers that divisible by 2 without leaving a remainder. Okay, so when we take um, odd numbers, they are divisible by 2 without. So when we take example of numbers, we include 1, 3, 5, 7, and so on. Okay, they are integers that are not, sorry, that are not, they can be divisible by 2. Okay, so they are not divisible by 2. So when we take 1, we can't divide it by 2. When we take 3, when we divide 3 by 2, there still be a remainder, that's 1. When we divide 5 by 2, there will still be a remainder, that is 1. So odd numbers, when divided by 2, must surely have a remainder. Okay, so that qualifies them as natural numbers. Why? Because they are also positive. Okay. When we take the next one is counting numbers, also known as natural numbers. Okay, because why? We said earlier that natural numbers are integers that mostly start from 1. Okay, so we take counting numbers mostly start from 1 to infinity. So definitely they qualify to be a subset of natural numbers. So counting numbers form the basis on which natural numbers are extracted. Okay, so counting numbers form the basis for natural numbers. Okay, let's move on. The fourth one, we have the whole numbers. The whole numbers are the set of counting numbers along with 0. Okay, so we take counting numbers. Counting numbers can barely start from 1 to, okay, so normally they start from 1 to infinity. But when we take whole numbers mostly or can start from 0 to infinity. Okay, so we don't mix them. We have the whole numbers, we have the counting numbers. So this qualifies a whole number to be a subset of natural numbers and a superset of counting numbers. Why we say superset of counting numbers? Because they start from 0, counting numbers start from 1. So that makes them the superset of counting numbers. And also they fall under the category of natural numbers, which we already said. Our next one is the prime numbers. The prime numbers are natural numbers greater than 1 that have no divisor other than 1 and themselves. So prime numbers are numbers which can be divisible by themselves alone, and they are greater than 1 that have no divisor. So they are numbers that are greater than 1 that have no divisors and themselves alone. So no other number except themselves. So some example of prime numbers, we have 2. No number can be divided, can divide 2 or can be a divisor of 2 except itself. So 2 divided by 2 should give us 1. 3 divided by 3 should give us 1. 5 divided, so we have their answers to be mostly 1. Okay, so this gives us prime numbers. They fall under prime. So example is 2, 3, 5, 7, 11. We can't divide 3 by 7, because if we divide 3 by 7, we have a remainder which will make it fall under odd numbers. Okay, which will make it fall under odd numbers. In this case, we are talking about prime numbers. Prime numbers can only be divisible by themselves. Okay, and 1. So okay, so let's move on. In our next topic, we'll be looking at other natural numbers. Okay, apart from the subsets of natural numbers we talked about recently, we're talking about other natural numbers. Okay, so the first on my list is square. Okay, square of a number or of a whole number. So we can have a square of a whole number. The square of a whole number is called the perfect square or square number. So example is n squared should give me n times n. So if I have 2 squared and I want to simplify it, I'll just break it down to 2 times 2, giving me 4. So 2 squared should give me 4. An example again, if I have 2 raised to the power 4 or 2 square 4, 2 exponent 4, sorry, I should have it broken down to 2 times 2 times 2 and another 2. So For example, this is what I'm talking about. So if I have 2 raised to the power 4, should be breaking down to 2 times 2 times 2 times another 2, which this should give me 4 times 4, and 4 times 4 we know is 16. So 2 as raised to the power 4 should give me 16. I hope we understand it. Okay, so we'll move on to the next on my list. Okay, we'll move on to the next on my list. That's the square root. Okay, the square root of a natural number multiplied by itself should give me the same number. This is very exciting, right? The square root of a number, okay, multiplied by itself should give me the same number. Example, if I have square root of n times square root of n should give me n. So for instance, I'm having square root of 2, okay, times square root of 2. I should have 2 as my answer, okay. I should have 2 as my answer. So to prove that, we have this, okay. To prove that, I'm having square roots of 2 multiplied by square root of 2 is equal to, so in this case, when we are multiplying square roots, we bring out the square root and multiply the numbers in the square root in one square root. So this should give me square root of 4, okay. And we know that square root of 4 is mostly multiples of that number. So if I take 4 and I go to the multiple of 2, I know that 2 times 2 should give me 4. So square root of 4 should give me 2. Okay, square root of 4 should give me 2. So this should be my answer. You can see that we are still having our same number, the same number here. In this, we are still having the same number over there. Okay, we are having the same number over here. That's this. Okay, so this is the same number 2. That is how we are proving our second point. Okay, so we are moving on to our next point on the list of other natural numbers. Okay, now let's move on. We have the factor of a whole number. The factor of a whole number is a whole number that divides exactly into it, leaving a whole number as the answer. So when we take example, 5 is a factor of 30. Since 30 is divided by 5, give us 6. So if we divide a number by a number, giving us a whole number, we term it as the factor of that number. So a factor of a whole number is a whole number that divides exactly into that number without giving a remainder. So that gives us a factor of that number. So 5 becomes a factor of 30 since it divides exactly into 30, giving us 6. Okay, now let's move on to our next on my list. This is a note. You have to know this, that 1 is a factor of every number. 1 is a factor of every number since 1 divides exactly into every number. Okay, so if I divide 1000 by 1, I'll still get my 1000. If I divide 2 by 1, I'll get my 2. Okay, so this is to prove it. We have 1000 divided by 1. Okay, I'll get my 1000 as my number or my answer. If I have 2 divided by 1, I will get 2 as my answer. I hope we get this concept. Okay, that's very good. That's very good. Now we move on to our next on my list. You should also note that every number is factor of itself. Yes, every number is a factor of itself, since every number divides exactly into itself. So if I take 2 and I divide it by itself 2, I'm going to get 1, which means it's a factor of itself. As we said earlier in our third point, we said a factor is a whole number that divides exactly into a number. So if I take 2 and I divide itself by 2 and I get 1, it's a whole number. So it makes it a factor of itself. Okay, so this is an illustration. If I have 2 divided by 2. I should be getting 1, okay, because 2 cancels itself 1 and cancels itself 1, which gives me 1 over 1, okay. And we also know that in the in the fourth point, we said 1 is a factor of every number, so 1 can be a factor of itself, so 1 divided by 1 should give me 1, okay. That makes it natural number. Okay, that's very good. Let's move on. We are moving on to our next subtopic, our subheading, which is common factors. Okay, we are coming to look at common factors. So we just talked about factors, which we said factors can go through numbers without giving a remainder. Okay, there are numbers that go through a number, a particular number, without giving a remainder. As we gave an example that 5 is a factor of 30, because 30 divided by 5 should give us 6. Okay, so now let's quickly dive in. Common factors: if 2 or more numbers have a factor in common, then the factor is called a common factor. Yes, as we said earlier. So if they are having, so if I'm having 2 numbers here, 2 huge numbers, and I find their factors, and there are certain number in their factors which give me a common number. So if I'm having set A and set B, and I'm having 1, 2, 3, 4 in set A, and I'm having 2, 5, 6, 8 in set B, 2 is in set B, 2 is in set A, that gives them a common factor. Okay, so that 2 is called a common factor. For example, we are having 3 as a factor of 12. Why? Because 12 divided by 3 gives me 4, and 3 is a common factor of 15. Why do we say that? Because 15 divided by 3 gives me 5. Therefore, 3 is a common factor of 12 and 15. Okay, so 3 is a common factor of 12 and 15. Why? Because 3 can be found in when I list the multiple, let me say the factors of 12 and 15, I can find 3 in there. That makes it a common factor of these 2 numbers. Okay, now we will be looking at one, highest common factors, since we are on common factors, and we will be looking at lowest common multiple. So let's quickly look at highest common factors. Okay, highest common factors. So some set of numbers may have 2 or more common factors, and the highest common factor of a set of numbers is the largest factor that they have in common. So if I'm having 2 sets and they are having a number in common, okay, they are having a number in common, the largest factor they have in common becomes my highest common factor. Okay, that is the largest number that divides exactly into all the numbers. So if I'm having set A, set B, that's a particular number. Okay, and then there's a particular number in their factors which can easily go through the 2 numbers without a remainder, and it's a huge number that becomes my highest common factor. Let's look at this is an example of highest common factor. So we have example 1.4 on my slide. It says find the common factor of 12 and 24. What is their highest common factor? So in finding the factors of 12 and 24, that's a primary thing that we know already. So that's why I didn't include it in my video, finding the common factor of numbers, because I really know that we've done it in a elementary level. Okay, so the solution, the factor of 12 should give us 1, 2, 3, 4, 6, and 12. So 1, 2, 3, 4, 6, and 12. And then factors of 24 is 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so now how do we list the common factors of 12 and 24? The common factors can be listed when we see a number which is appearing in the set A and set B, that's in the 12 factors of 12 and factors of 24. Okay, so when we look at it, what do we see? We can see that there is 1 in A, there is 1 in 24, factors of 24, there is 2 in factors of 12, there is another 2 in factors of 24, there's 3 here, there's 3 here, 4 is here, 4 is here, 6 is here, 6 is here, 12 and 12, okay. So that's those numbers becomes our common factors. So it is listed over here. You can see it over here. It is listed over here as our common factors. Okay, as our common factors. Now let's answer the question. That's what is the highest common factor. So how do we dig or dish out the highest common factor? As we said earlier, the highest common factor is the largest number in the common factors of two numbers, okay, that can easily divide the numbers without giving a remainder. So in looking at this, we have 1, 2, 3, 4, 6 and 12. So which of them is the highest? Probably 12 is the most highest. So looking at 12, can 12 go into 12? Yes. So without giving a remainder. And 12 can go into 24? Yes, without giving a remainder. Okay, that's into 2. So 12 will go into 12 1 and 12 will go into 24 2. So that simply means that 12 becomes our highest common factor. Okay, so on these notes, I would like you to solve example 1.4 on your own. Okay, solve example 1.4 on your own. You can solve it on your own. It's very simple. Just try it out. Okay, that's very good. Now let's move on. Okay, so this is another example. Okay, this is a real life example or a word example. So Kweku has a rectangular garden measuring 24 meters by 40 meters. He wants to divide it into square plots of equal size. What is the largest sized square he can use? So we are talking about Kweku having a garden measuring 24 meter long and 40 meter wide. And he wants to divide this plot of land into square plots of equal size. So what is the largest sized square he can use? Now let's move into our solution. So this is a solution. The information we saw earlier gave a problem that Kweku was having a plot of land, okay, which measures 24 meters long, 40 meters wide. So the 24 meters and 40 meters gives us numbers we are coming to work on, okay. So before starting, we look at the factors of the numbers we were given in our question. So we look at the numbers of the factors of 24. That gives us 1, 2, 3, 4, 6, 8, 12, and 24. Okay. And the factors of 30, that gives us 1, 2, 4, 5, 8, 10, 20, and 40. So how do we look for our HCF? So before looking for our HCF, we look for the common factors. And what are the common factors? The common factors here can be seen as 1, 1, 2, 2, 3. No, 3 shouldn't be part. 4, 4, okay. And what again? 8, 8. And I think that's all. Yes. So we have 1, 2, 4, and 8. 1, 2, 4, and 8. Okay. So our common factors is 1, 2, 4, and 8. Okay. So in these common factors, which of them do you think is the highest? Which of them do you think is the highest? And the highest, I think I should take it to be 8. Okay, the highest should be 8. So if the highest number is 8, can 8 go into these numbers without a remainder? Yes, it can go through. So therefore, 8 becomes my highest common factor. Very simple, right? Very simple. Okay. So therefore, the largest square he can use has a side of what, 8 meters. Okay, very very simple, very simple. Okay, let's move on. So we are moving on to the lowest common multiple. Okay, lowest common multiple. So the lowest common multiple, so let's imagine we're having two numbers, okay, which have a multiple in common. Then the multiple is said to be a common multiple. So for example, we have 2, which has multiples of 2, 4, 6, 8, and 10. Okay, and we have multiples of 3, which denotes 3, 6, 9, 12, and 15. So in this case, we can see that in the multiples of 2, we are having a particular number here that is 6, and then we are having 6 also here. Okay, so since we're having the 2 there, that becomes automatically a common multiple. Okay, our lowest common multiple, because it can be found in both both set of numbers. Okay, yes. So let's look at if two or more numbers have more than one multiple. So this is when they have one multiple, and this is when they have one or more multiple. Okay, when they have more than one multiple. The lowest common multiple is the smallest multiple they have in common. So if we are having a numerous number of common multiples in some particular sets, okay, it can be 2 sets or 3 sets, and there are many multiples to be found in them. There are many common multiples to be found in them. We take out the least one because we are looking for the lowest common multiple. Unlike the highest common factor, we take out the highest common number. Okay, that's the difference. In highest common factor, we take out the highest common number, and then in lowest common multiple, we take out the lowest common number in the numbers, or the set of numbers. Okay, so let's look at an example. Okay, so this is an example. Example 1.8 says find the lowest common multiple of 15 and 18. So before we find the lowest common multiple, we list the multiples of the numbers. So multiples of 15 are said to be 15, 30, 45, 60, 75, 90, 105. Okay, and the multiples of 18 should be 18, 36, 54, 72, and 90. So we can see that the multiple starts with the number you are looking at. Okay, so when we take multiples of 15, we should start from 15, because 15 times 1 gives us 15. Okay, yes. When we take 18, we should start from 18. Why? Because when we multiply it by 1, it gives us the same number. So now we have the multiples of 15 and 18. Now, to be able to look at the lowest common multiple, we list out the common numbers. Okay, we list out the common numbers. So how do we list out the common numbers? When we look at the multiples of 15, I can see we are having 15, 30, 45, 60, and 15 cannot be found in the multiples of 18, neither 30 nor 45, 60, 75. But I can see 90 here and 90 here. Okay, 90 can be found here, and the same time found here. So we can see that it's a single common number. So automatically that becomes a common lowest common multiple, or the least common multiple. I hope we understand it. Okay, let's look at another example. Okay, this is another example which is in a word example, or let me say a real life example. So a Kia belongs to 3 committees in a junior secondary school. One committee meets every 6 days, another committee meets every 14 days, and the third meets every 21 days. They all meet on the first day of the school. Okay, they all meet on the first day of the school. So how many days after this will they meet on the same day? This is a very very tricky question, but it's not difficult. So we just dive into the solution. So this is the solution of our problem. So the information given in the problem suggests we make use of LCM. Okay, so the LCM of 6, 14, 21 will give us the answer of the question, of the word problem we had. Okay, so before we can look at the LCM, we'll have to list the multiples of 6, multiples of 14, multiples of 21. Okay, so now the multiples of 6 could be seen here. We are having 6, 12, 18, 24, 30, 36, 48, and 18. Okay, and the multiples of 14 starts with 14, 28, 42, 56. Okay, 56. And the multiples of 21, we have 21, 42, 63, and it goes on, it's infinite. Okay, so that's why you can see this triple dots here. The triple dots here can be found over here too, and at the same time here. Okay, so now we've listed common multiples, multiples of various numbers. So the multiples of 6 have been listed, 14 and 21. So now, before we can look at our list common multiple, we need to list out the common multiples of these three numbers. So how do we dish out the common multiples of these three numbers? When we take 6, we have 12, 18, 24, 30, 36, 42, 48, and 14, 14, we have 28, 42, 56, and 21, we have 21, 42, 63. So analyzing it critically, we can see that all of this are having 42. Okay, the multiples of 12 is having 42 here. This is having 42 here, and this is having 42 also here. Okay, so that means 42 automatically becomes our LCM, or our least or lowest common multiple. So therefore, the committee next meeting on the same day will be 42 days after the first meeting. Very, very simple. I hope you understood it. So their next meeting will be on 42 days after their first meeting. So next we are moving on to testing of divisibility. Okay, testing for divisibility. When we talk about divisibility, it's testing for how we use numbers to divide other numbers without the help of calculator, or yes, without the help of calculator. Okay, so now let's move on. We'll be talking about some divisibility rules. Okay, talking about some divisibility rules, the rules that will help you in dividing numbers without the help of calculator. So the divisibility rule 1 is divisibility by 2. When we take 2, how do we divide 2 by numbers? Okay, how do we divide a number by 2? Okay, so rule 1 states that a number is divisible by 2 if its last digit is even. So any number at all, it can be 3-digit number, it can be 4-digit number. All we have to know is if the number last digit is an even number, then it's divisible by 2. So for example, if we take 246, 246 is divisible by 2. Why? Because 6 is an even number. Okay, which when we divide 6 by 2, we won't have any remainder. Okay, there won't be any remainder. As we said earlier in our lecture here, we said that even numbers divide without a remainder. Okay, so 6 is an even number because it is divided by 2 without giving a remainder. Okay, so that makes it divisible by 2. So 246 can be divided by 2 because 6 is divisible by 2. Rule number 2, we are taking 3. When we are dividing a number by 3, what is the rule attached to it? A number is divisible by 3 if the sum of its digits is divisible by 3. So if we sum up all the digits and is divisible by 3, why not 3? It can be divisible by 3. Okay, so let's take example. When we take 372, it's very difficult sometimes to do this division, so for you to know that, okay, this is divisible by 3, so let's add the numbers. So 3 plus 7 should give us 10, plus 2 give us 12. Now let's look at 12. Can 12 be divided by 3? Oh yes, it can. So That means 372 can be divided by 3 without giving a remainder. Okay, so that's our rule number 2 of testing for divisibility. Okay, so rule number 3, divisibility by 4. When we take 4, what is the rule attached to when we are dividing a number by 4? So the rule states a number is divided by 4 if the number formed by its last 2 digits is divisible by 4. Okay, if the number formed by its last 2 digits is divisible by 4. So for example, if you're having 1448, it is divided by 4 because 48 is divisible by 4. Very simple, right? So if you're having 3 numbers, 4 numbers, 5 numbers, all you have to check is the last 2 numbers. If they are divisible by 4, definitely the whole number or the whole digits of numbers can be divisible by 4. Okay, very simple. Let's look at our fourth rule. Our fourth rule is divisibility by 5. Okay, so what is the rule attached to when we are dividing a number by 5? Okay, so a number is divisible by 5 if its last digit is 0 or 5. Very simple. Okay, if its last digit is 0 or 5, so you just make sure if the last digit of the numbers, okay, is 0 or 5, that means it can be divisible by 5. So let's take 1350 as an example. When we are dividing 1350, we are having a number there and you are being asked what number can go through 1350. Oh, as soon as you just look at it, you know that, oh, okay, it's ending with 0, so it can be divisible exactly by 5, okay, without giving any remainder. So let's look at our fifth rule. Our fifth rule is divisibility by 6. Divisibility by 6. So what is the rule attached when we are dividing a number by 6? So a number is divisible by 6 if it is divided by both 2 and 3. Okay, so example, we have 198. 198. When you take 198, the last number, okay, the last number, as we said in the divisibility by 2, we said that the last number should be even. And divisibility by 3, we said when we add the whole number or the whole numbers or the whole digits of numbers and they are divisible by 3, that means it can be divided by 3. So divisibility by 6 is the combination of divisibility by 2 and divisibility by 3. Very good. That's very simple. So divisibility by 6 can be the combination of divisibility by 2 and divisibility by 3. So divisibility by 2 says that the last number should be even, and divisibility by 3 says that when we add the whole numbers, it should be able to be divided by 3. So when we look at 198, 8 is an even number, okay? It can be divided by 8 without giving a remainder. And when we add the whole numbers, 1 plus 9 giving us 10 plus 8 giving us 18. And how do we divide 18 by 3? We know that 18 can be divided by 3 to give us 6. Yes, 6. So it's a whole number without a remainder. So that means 198 can be divided by 6 without giving a remainder. Very simple. Okay, so this brings us to the end of our lecture, which is the first lesson on numbers and the subtrahend operation of numbers or properties of natural numbers. Okay, so this is an online or e-learning platform which is Legend in Learning, and we are available on all platforms. Okay, so you can email us directly to the email number here, the email address here, and then the mobile numbers over there. You can easily talk to us directly on WhatsApp, email. We are good, and we'll reply to you quickly. Okay, so once again, thanks for watching, and don't forget to subscribe, like the video, and share the video. So don't forget to click on the notification bell if you need another video, and we'll be uploading more of educative videos here to educate you, to give you the lessons which you might not be given in the classrooms. Okay, so thank you for watching. the Legend in Learning digital class. Bye bye.